Assalamualaikum and good day everyone. Today we will continue our mass balance with reactive process. Today we'll be looking into the balances that we can use in solving mass balance problem with reactive process. Actually, we have three methods that we can use to solve mass balance with reactive process. We have the first method known as molecular species balance, second method atomic species balance, and the third method, extent of reaction, where extent of reaction we have used it in the previous video to solve our question, right? Okay, each of this method, it has their own degree of freedom analysis. Okay, before we solve our mass balance, the first thing that we have to do is we have to, from the question, we have to draw our process flow diagram and label it correctly, right? And then we have to do our degree of freedom of analysis. Remember? Okay, so that's the same thing that happens in mass balance in reactive process, where you have to draw your process flow diagram and conduct your degree of freedom analysis. However, degree of freedom of analysis for molecular, atomic, and extent of reaction has different requirement. Each of these has different requirement, where in order to do degree of freedom analysis, we have to understand the requirement for molecular, atomic species, and extent of reaction. So we'll look into degree of freedom after this. But before we go to degree of freedom, I would like to show you an example of how we use atomic species balance in solving problems. Previous video, we actually have done example 4.6-3 in your textbook. From the textbook, the method used to find the unknowns in the question was using extent of reaction. Okay, so in this part you can see that what we have, this is a summary of the textbook that I have written here. So this is the process, and these are information given, and we draw the process flow diagram, right? Okay, so now let's say this time we want to solve this same question using atomic species balance method. Okay. So now we are trying to solve the unknowns for this question using atomic species balance method. Okay. Once you know the equation, you know some information. Actually, some information give us some information about the product that goes out from the product line. Okay. So from fractional conversion, we'll get the amount of C2H6 or ethane unused or balanced that go out from the process. Ethane that's not being used go out from the process, where you get 42.4 mole. So we draw it here, we write it here. Okay, from fractional yield, using the equation of fractional yield, you actually can calculate how much ethylene C2H4 that actually being produced with this process. So from the fractional yield equation, you get ethylene equivalent to 40 mole. If you want to know how we get this previously, you can check from my previous video. Okay? Or you can look into equation 4.6-3, where they solve it using, you can look into the example in the textbook 4.6-3. Now, let's see. I would like to show you how we solve this question using atomic species balance method. So from the information given, we still have another two unknowns that we need to solve. That is the number of mole of hydrogen produced, and number of mole of methane produced, CH4. Okay? So let's use atomic species balance to determine these two compounds. In atomic species balance, we need to know what are the atomic element being used in your process. So we have C, we have H. We only have C and H element. So that will be the balance that we have to do, that we only have to do for C and H, because we do not have other element, just we have C and H. Okay, so let's do this. If we use C balance to determine CH4. C balance, yeah? For atomic species balance, in equals to out. In amount of atom goes in equals to amount of atom goes out. Okay? So what we have, in order to do atomic species balance, the process that goes in is we have 100 mole of feed goes inside, which have 85 mole of C2H6. 85 mole of C2H6 we have to solve it in terms of C. From our feed, we only have this in terms of C. So we see 85 mole C2H6, and then you have to time with the relationship between 1 mole of C2H6 equivalent to 2 mole of C, correct? In 1 mole of C2H6, we have 2 mole of C. Okay, this. So we cancel off this, we have 85 times 2 mole of C equals to, what are the compounds that contain C in our product line? So we have this, and we have this. So we have to do the in equals to out. Will we do for this one first? This plus the next compound plus one unknown So what do we get at the end? We have 170 mole of C equals to 84.8 mole of C plus 80 mole plus C, 80 mole of C plus which is for CH4, right? Okay, so the NCH4, finally we have NCH4 produced is equivalent to 5.2 mole. Okay, we'll resolve for NCH4 5.2 mole here. Now let us use H balance to solve for H, because we have another unknown, right? So let's use H balance to solve that. H balance. So H balance, we will get H2O that we need to know. Remember, I still use notation of O here because I referred to the previous method that we used. But what I want is actually the number of hydrogen out, yeah? Okay, so we still use this. We have, so in feed we have mole in, we have H in C2H6. 85 mole of C2H6 in terms of H will be equivalent. So we have to find all the compound that comes out from reactor that have H atom in it. So this one, the first one, plus, who else have H? We have ethylene, who else? Okay, and then we have NH2, right? Which is a mole of H2. 1 mole H2, 2 mole of H, and finally plus with N, sorry, you already have that answer just now, 5.2 mole CH4. Okay. Lastly, we have number of mole of H2 produced equivalent to 37.4 mole. So you can check with your answer that we solved before using extent of reaction. So you'll get the same answer. Either you use extent of reaction or if you use atomic balance. Thank you.